Hello everyone. In this video, we are going to discuss about the law of conservation of energy. Activity 1. Skier moving down the hill. A skier of mass 50 kg is standing at the top of a hill at 100 meters high. Let's investigate his kinetic and potential energies with respect to his motion and vertical height. When the skier is on the top of the hill, it's clear that he stores potential energy due to his vertical height. By applying the formula PE equals m multiplied by g multiplied by h, his potential energy is equal to 7,350 joules. As the skier moves down the hill, his height decreases, and similarly, his potential energy. When he reaches the bottom of the hill, his height will be zero, and consequently, his potential energy will be null. How can we describe the potential energy of this skier as he goes down the hill? It's clear that the potential energy is decreasing from its maximum value at the top of the hill to be null at the bottom. Now, let's describe the kinetic energy of the skier. We already said that the kinetic energy is the energy of an object due to its motion. At the beginning, the skier was at rest. How does the word at rest describe the speed of the skier? If your answer is his speed is equal to zero, you're correct. And then he's not in motion. Consequently, his kinetic energy is equal to zero. As the skier moves down the hill, his speed will increase and similarly his kinetic energy. How can you describe the kinetic energy of this skier as he is moving down the hill? The kinetic energy is increasing from null on the top of the hill to reach its maximum at the bottom of the hill. By taking a quick look at the change of the kinetic and the potential energies, we can easily notice that the potential energy is decreasing from maximum to null, while the kinetic energy is increasing from null to maximum. What does that mean? If your answer is the potential energy is transformed into kinetic energy, then you're correct. What's shown in this experiment describes the law of conservation of energy. What does this law state? The law of conservation of energy states that energy is neither created nor destroyed. It is transformed from one form to another. In this case, the potential energy was changing to kinetic energy. Activity 2. Introducing mechanical energy. As we are familiar with kinetic energy and potential energy, it's time to introduce mechanical energy. Mechanical energy is the sum of potential and kinetic energies. What's interesting about mechanical energy is that its amount stays fixed during the motion. In the previous example, the potential energy of the skier was decreasing while his kinetic energy was increasing. What is lost as potential energy is gained as kinetic energy. So, the sum stays fixed. What is the amount of kinetic energy of the skier at the bottom of the hill? In order to calculate the kinetic energy, we need to replace the value of the speed in the formula ke equals half multiplied by m multiplied by v squared. But in this case, the value of the speed is not mentioned. Then how do we figure out the kinetic energy? Let's calculate it from the mechanical energy. The amount of potential energy is previously calculated from the formula PE equals m times g times h, and its value was equal to 7,350 joules. Similarly, we agreed that the kinetic energy was equal to zero, as there is no speed initially at the top of the hill. Let's find the mechanical energy. Mechanical energy is equal to the potential energy plus the kinetic energy. By replacing each term by its value, mechanical energy is equal to 7,350 plus 0, and then it's equal to 7,350 joules. Now, let's find the value of the energy at the bottom of the hill. We already said that the value of the mechanical energy stays constant during the motion, which means the value of the mechanical energy must stay 7,350 joules. What is the value of the potential energy? If your answer is 0, you're correct because the height is equal to 0. Now, let's figure out the kinetic energy. The mechanical energy is the energy that is equal to the potential energy plus the kinetic energy. Now, let's replace each term by its value. In the place of the mechanical energy, we write 7,350, and in the place of the potential energy, we write 0. This equation will show clearly that all the potential energy stored by the skier on the top of the hill is completely converted into kinetic energy at the bottom of the hill. Have you ever visited Ferrari World in Abu Dhabi? If yes, you must have tried the Turbo Track, this amazing game that is formed of a wagon that travels vertically to a maximum height of 64 meters. This wagon is launched at the speed 28.33 meters per second, and on the highest point, the wagon stops for parts of a second, then goes back to its initial point. Let's describe the energy of the wagon. At the beginning of the motion, the wagon is moving with a speed of 28.3 meters per second. What type of energy does the wagon have? If your answer is kinetic energy, then you're correct. What about the potential energy? As the wagon is still in contact with the ground, its height is equal to 0. By replacing height by its value in the formula PE equals mgh, the amount of potential energy will be equal to 0. Now, let's describe the energy of the wagon at the highest point of the track. The wagon stops for parts of a second. When an object is stopped, this means that it's not in motion, and then its speed is equal to 0. By replacing speed by its value in the formula ke equals half mv squared, the amount of kinetic energy is 0. Now, what about the potential energy? We already said that the gravitational potential energy is a stored energy in an object due to its vertical height. When the wagon is at its highest point, the value of the gravitational energy is maximum. So, Let's describe the kinetic energy of this wagon. The wagon starts moving faster and then stops at the top of the track, and accordingly, the kinetic energy decreases from maximum value to be null at the top of the track. How can we describe the gravitational potential energy of this wagon? At the beginning, the height is zero, and consequently, the gravitational potential energy is null, and then it increases to its maximum value at the highest point. As the height increases, the kinetic energy decreases, and it is transformed into gravitational potential energy. Consequently, energy is neither created nor destroyed, it is just transformed from one form to another.